Okay, welcome everyone to lesson unit 5, lesson 6. In this lesson, we are going to start to learn about algebra tiles. If you were here in the classroom, well, I say here, this is my house, but if we were all in the classroom, Miss Hanson and I would have a set of algebra tiles for everyone to work with to, learn algebra. But we're not. So I have some here at my house. But these are unfamiliar for most of us. Most of us haven't worked with those. Base 10 blocks? Yeah, we say, yeah, we've worked with them. These, though, we say, no, we haven't. And we're not quite sure what they might be about. So this lesson is actually just to introduce you to algebra tiles. And then I'll do another lesson on actually what's in the lesson. This is just to help us understand the materials. So to do that, we're going to start with not something that's unfamiliar like this, but something that we actually know about. So hold on, I'm going to bring it out just one second. And we're back. And we're back with Pringles. So I don't know about you, but I love Pringles. They're one of my favorite chips. So the question, though, is we can't see the Pringles inside. We don't know how many there are. But we're pretty sure that if we're at the grocery store and we're thinking about buying Pringles, that every can has the same amount of Pringles. We don't have to try to lift them up and sort of weigh them and think shake them a little bit and be like, is this the can that has more Pringles, or should I put it back and take a different can? No, we know that when they're at the Pringle factory, however they make them, I don't know, but they put the same number of Pringles in each can. So when I grab a can off the shelf, I know I'm going to get the same number of Pringles. So then I open it up and I find out how many Pringles there are. I don't know right away, but I know that as soon as I open it up, I'm going to know how many Pringles are there. Of course, the hazard at our house, and maybe this is the hazard at your house, is as soon as they're opened, we eat all the Pringles and we still don't know how many Pringles were in there. But we're pretty sure that if we go back to the store, we'll get the same number of Pringles in the next can, and we probably won't know how many are in that can either, just because we eat them all. So you wonder, okay, how does a Pringles can, an eaten empty Pringles can, how does that make sense with the algebra tiles that Ms. Cooper was just showing me? Well, here's how. Let's take a look at page 236 at Puzzled Penguin. Hold on one second, I'll be right back with you. Okay, weirdly, we're going to start at the very end of the lesson with Puzzled Penguin. Because it says, Dear math students, I just had a math quiz about equivalent expressions, and here are 2 problems I got wrong. Take a look at the first one for Puzzled Penguin. 4x plus 3, and he's got equals the same thing as 7x. So that's what we're going to use the Pringles to help us think about. Okay, so first, as a point of remembering, 4x. Remember, when there's x, whenever there's a letter in math, it always means just a mystery number. It's just a number we don't know. And it doesn't matter what letter it is, it just means it's a number we don't know. So remember, when a letter and a number are squished right next to each other, there's something missing in there. There's something invisible in between there. Remember what the invisible thing is? Multiplication sign. So 4x really just means 4 times x. There's an invisible times sign there. You just have to remind yourself, when a letter and number are squished next to each other, I know there's a times sign. Now, the other thing we know about times, say it with me, times means exactly. If I was at school, I'd have to give you a piece of candy if you were the first one to say it. Times means groups of. So this 4x really means 4 groups of x. X is a mystery amount. So this means we got 4 groups of a mystery amount. Aha, you say, the plot thickens. It comes back to the Pringles cans. So the question is, we don't know how many Pringles are in each of these cans, but we know that's the same amount because that's how things go at the factory. So we now have 4 groups of a mystery amount of Pringles. 4 groups of a mystery amount of Pringles. But remember that Puzzled Penguin, what he was actually saying was 4 groups plus 3. So what that means is he has 4 cans of Pringles, and they're not the cans like my cans earlier where they're empty. These ones are actually full. So there's 4 full cans of Pringles. We don't know how many's in it, but we know there's 4 whole cans, and he said there's also 3 additional Pringles. So 4 whole cans and 3 additional Pringles. Now remember, what Puzzle Penguin was telling us was that 4x plus 3 equals 7x. That's what he said. He said 4 groups, 4 cans of Pringles. We don't know how many is in each, but 4 cans of Pringles plus 3 more Pringles equals, look what he said it equals, 7x. That means 7 times x, 7 groups of x. So that means 4 cans of Pringles, that we don't know how many is in each one, plus 3 more Pringles is the same as, and that's what equals means, is the same as, work the same as 7 cans of Pringles. Does that make sense? No, that's totally wrong. And if you like Pringles like our family, you're going to say that's totally wrong. 4 cans of Pringles plus 3 additional Pringles does not give us 7 cans of Pringles. No matter how many is in the can, that still doesn't make sense. So that's how we're using Pringles to help us understand variables in algebra. Because if I have 1, 2, 3, 4, I know what you're thinking. Does she actually have 7 cans of Pringles? And the answer is no. I wish I had 7 cans of Pringles. But we can easily tell by using the cans that 4 whole cans of Pringles plus 3 additional little Pringles in no way could possibly equal 7. I do have our empty one though. 7 cans, pretending to put that out 3 more times. 7 cans of Pringles. It just doesn't make sense. So that's how algebra works, is when there's a letter, it means we just don't know how much that is in there, but we know that it's all the same. So just like each can of Pringles is the same, all 4 of these groups of X are all the same. We don't know what's in them, but we know they're all the same. All right, well, I hope your brain hasn't exploded yet, because that would be messy on your computer. But let's use the same Puzzle Penguin question, but with our algebra tiles now. So our algebra tiles, and you'll see these in your book, and that's why we're using them. And I know that you don't have them at home, and that makes it hard. But I'm going to show you what they're like here, and in my videos, I'm going to show you both our algebra tiles, as well as maybe something you could use at your house, that you just have at your house, that you could use to be able to model this, because it really, really is one of those things. Like you hear me say day after day after day, our brains learn new things first with being with materials. And it doesn't matter if we're a 30-year-old or a 10 or 11, 12-year-old, or my age, or if you have a PhD in mathematics, is how we learn math. The very first time we're exposed to a new concept is to actually use materials. So please, please, please use materials. Find materials at your house. They don't have to be my materials. They don't even have to be a whole ton of cans of Pringles, but they do need to be something that makes sense for the problem. So please find materials. So here we go. We have these little pieces, these little squares. They're blue on one side and red on one side. Those are going to equal 1, just like 1 little Pringle. So in our Pringle example, there are my 3 little individual Pringles right there. Now, it would be awesome, but we're not going to use Pringles can. In our book, it just uses like a long shape. We don't know what this long shape is. It's not even like our base 10 where we can kind of count off a certain number, like 1 of those little squares equals like a 10 rod, and a 10 equals a big square, and 10 squares equals the cube. It's not like that. This just is a number, just represents some group of something, some number. Kind of like, remember in class I was talking to you about like a little dark bag like this. We can open it up and we can look inside and see how many, and we can count them. But when it's closed up like this, we don't know how many is in it. We just know it's 1 bag. That's the same thing with this. So this is 1, 2, 3, 4, kind of like our Pringles cans. There's 4 things represented groups. We don't know how many is in there. Whoop, my hair's doing something weird there. We don't know how many there's in there, but there's 4 groups of a mystery amount. Then there's 3 more. And Puzzle Penguin is asking us whether that makes sense to be 7 groups of a mystery amount. I guess I have to dig in my, oh, here we go. Just got to reach over and get them from over here. Now, you might be thinking, does it matter if they're purple or red? No. At this point, it doesn't. At some point, we might use the colors to mean different things, especially when we're talking about integers or negative numbers, we might do that. But for right now, it really doesn't matter. I'm just putting them all the same color because I'm annoyed by it if they're not. So here's the question, and you can kind of tell by looking. If we have 4 cans of Pringles, 4 of something that we don't know how many's in there, but it's a mystery, we'll get 4 of them, plus 3 individual things, does that in any way make 7 of a group we don't know? And again, we can kind of see like, no, that doesn't make sense. That's not an equal situation. If it's helpful for you to continuously go back and think of a Pringles can where we know all the Pringles are the same amount, but we don't know how many it is, use this on through the unit. Keep thinking to yourself about Pringles cans if that's helpful. I think for me, it's really helpful to visualize that. Whoops, that was Coco. You heard barking there for a second. Coco, no thank you. So it's helpful for me to visualize 4 Pringles cans plus 1, 2, 3 individual little Pringles, and whether that makes sense with 7 Pringles cans. That's helpful. Now you might say, okay, but I don't have 7 cans of Pringles, which neither do we. And I also don't have algebra tiles. Well, what else could I use? Well, let's think about that a minute. Okay, well, you know, I love Legos. We got a lot of Legos at our house, and I know some of you also have a lot of Legos at your house. So you use Legos. There's 3 individual ones. Now, I get that we actually, see how big these are, but we're just using them to represent a number, some number that we don't know. So some number that we don't know, and they're all the same. And even though in this I didn't even find them all the same, it's okay. As long as it doesn't confuse you to say like, oh, wait a minute, that one looks bigger. That one's wider. Well, it is. But if it doesn't bother you or confuse you, and you know that every single thing I'm using here is all just worth the same, then you can again tell 3 of some number, 4 of some amount, plus 3 individual ones still wouldn't make 7 of some mystery amount. And again, you can picture those all as Pringles cans, if that helps you, because we definitely can see how that makes sense. So that might help you with this. No Legos at your house? No big deal. What about just pieces of paper? You can cut little pieces of paper for the individual ones. So anytime they're the tiny little squares, they'll just mean individuals. And then just cut, and really, I kind of cut them in the shape of the algebra tiles or in the shape of a Pringles can, but you could cut them any shape at all. You could cut them in the shape of got really crafty, you could actually make tiny little bags like this. That would be super fun. That'd be another little fun project. Ooh, that's another video. I could make a video on that. Actually, that would be kind of fun. So you could make even little bags like this. But as long as you know that it represents a group of something that has the same number in it, that we don't know how much it is. So paper, that works too. So here's what I'd like you to take away from this video. Please, please, please use something that you can get your hands onto that makes sense with this math to help you understand it. Please do that. Don't just watch me do it. Please do it. And if this helps you, you could say, family, what I really need is some Pringles because I got to do my math. You know the other thing. Hold on one second. Chocolate. So got some individual M&Ms here. That's going to work perfectly for the individual. As you can see, I had a bit of a candy bar disaster. I was trying to cut these into kind of, how we're always talking about candy bars in class and how they divide so easily. So I took my knife and I tried to cut them, and they just broke up into these little things, and some of them were like just broken like that and everything. So the big dog. So you could have individual little M&Ms and then take a big dog candy bar and just cut it into a few pieces. You don't know how much chocolate is actually in those pieces, but you know that it's going to be, well, if you cut them the same, it'll be all the same. So again, maybe you could get your family to in on math. See, do at home math. Love it. We'll see you next time. Good luck.